When most people think of satellites, they think of, a big metallic box with solar panels and a communications dish. This is mostly accurate, and the greater amount of satellites orbiting Earth or Mars looks something like that. But in the past 20 or so years, there has been a growing new form of satellite. Yes, you read the title. This video is about CubeSats. A CubeSat is typically a satellite that is no heavier than 1.3 kilograms and is made up of modules of 10 centimeters times 10 centimeters times 10 centimeters. They are usually launched by universities or schools, but they have some promising uses in commercial spaceflight and communications. It usually costs around $10,000 to $20,000 to build a CubeSat, and prices go as low as $3,000 if you really do some budgeting, but launch costs go as high as $120,000. Yeah, pretty pricey. The cheapest you can get would be from Rocket Lab, which we will go into shortly, and you can get your CubeSat safely to orbit for only $70,000. Now, let's talk about the design of a CubeSat. A large amount of CubeSats are composed of regular off-the-shelf parts, which, other than their size, sets them apart from other small satellites. CubeSats are usually made out of aluminium or something similar, and have solar panels on most of their faces, sometimes floating out to harness more of the sun's energy. They usually use rechargeable lithium-ion batteries, which are a good choice for spaceflight, as they are lightweight and energy dense. Like most spacecraft, CubeSats use multiple computers for different tasks, in some cases using the Raspberry Pi microcontroller as its brains. The Raspberry Pi is a ridiculously cheap computer that can be used as a tiny PC with its own operating system, or be coded for different tasks like being a smart home hub, controlling an autonomous drone, and in this case, a flight computer. There's one thing that all spacecraft have in common, no matter what. They all have some way to communicate back to Earth. For CubeSats, these are usually small antennae that operate on UHF or VHF bands, and are commonly around 10 centimeters long. They usually communicate with relatively small radio dishes on the ground, exchanging scientific data and software updates. Some, but not all CubeSats have built-in propulsion systems. These are used for a variety of uses, such as technology demonstrations or space debris avoidance. The majority of these use some form of cold gas thruster or monopropellant engine, but there have also been cases of ion engines and solar sails being used. Not many CubeSats use traditional rocket engines because of safety concerns around damage to a host vehicle in the event of explosion, but one of NASA's CubeSats has found an interesting way of avoiding this problem. NASA's PD-1 satellite launches with a canister of water and later converts it into hydrogen and oxygen in flight using electrolysis. The hydrogen and oxygen are then used as fuel afterwards. Perhaps the most well-known CubeSat is actually Explorer 1, which was the first American satellite and spacecraft. Although it's not really a CubeSat, it's very close. The first official CubeSats were launched in 2003, after the specifications were developed and set by the California Polytechnic State University and Stanford University in 1999. Rocket Lab started up as a small company, which was founded in June 2006, and since then it has made large advancements in space exploration technologies with their carbon fiber Electron rocket. The Electron has 9 Rutherford engines, producing a thrust of roughly 20,000 newtons each, and the Rutherford engine is actually the first rocket engine in history to run on an electric pump. Recently, there has been a lot of big news around the announcement of the Neutron rocket. The Neutron is what Rocket Lab CEO envisions as a 2050 rocket, with its amount of reusability only matched by the Starship. Neutron will be able to lift 8 tons to low Earth orbit, and will be 40 meters tall with a max diameter of 7 meters at the bottom. The fairings have a unique and innovative design, never leaving the spacecraft, and instead opening in 4 petals to release the second stage and payload. Anyway, Rocket Lab is playing a key part in the CubeSat industry, providing a reliable launch service at a relatively low cost. In the future, CubeSats could be used in mega constellations similar to Starlink. One of my favourite ways to use such a network is if every CubeSat contained a small telescope, forming a giant 360-degree camera to peer deeper into the universe, larger and more powerful than any telescope ever made. The first probes that make it to other stars would likely be tiny chips on a solar sail. This would need a very large laser to power it, which would be another good use for such a CubeSat mega constellation. But then again, if such a laser was weaponized to be focused on Earth to a specific location, the result would be mass destruction on a huge scale.